So I'm taking a look at problems that have to do with density. Now, I would imagine in science class at some point someone went over the formula that density equals mass divided by volume. I would imagine that they made this little triangle. Okay, so I'm just going to remind you of how this triangle is handy. If you want to find mass, you multiply density times volume. If you want to find density, you do mass divided by volume. If you want volume, it's mass divided by density. So keep that in mind. The way I like to do these problems is I like to use unit analysis. So in other words, I look at what units they're asking me for in my answer. All right, and then I work backwards to figure out how to get those units if I'm ever unsure about which operation to use. So taking a look at number one, a shipping container is in the shape of a right rectangular prism. They give you the dimensions 12, 8.5, 4. And then they're asking you to find, they're telling you that the container is completely filled with contents that weigh on average 0.25 pounds per cubic foot. What is the weight in pounds of the contents in the container? So note, when you get your answer, you do not want the cubic feet. So since this is 0.25 pounds per cubic foot, I would get cubic feet to cancel out by multiplying. So I can get the weight by multiplying the 0.25 pounds by the volume, all right? So this weight is functioning as the mass here. So you just type that into your calculator, 12 times 8.5 times 4 times 0.25. So as you see, I got 102. In question 3, they're giving you the density is 752 kilograms per cubic meter. If the trunk of a white oak tree has a circumference of 4.5 and a height of 8, what is the approximate number of kilograms? So again, you need volume to cancel out because we want to be left with kilograms. So we're looking for mass again. So I'm just going to multiply this, but I need to think about it. Circumference is 2 pi r. That circumference is equal to 4.5 meters. So what I need to do is I need to solve for r. So my r would just be 4.5 divided by 2 pi. That would be my r. So when I do the volume, okay, volume is pi r squared times h. So I have 752 times pi, and then my r squared is going to be 4.5 over 2 pi times 4.5 over 2 pi. Okay, you can cancel out one of these pi's, and so on your calculator you have 752 times 4.5 squared divided by 4 pi. I realized I'd left out the height, so I interjected it here. You can see I put in my 8. So the answer is choice 2. When I typed this into my calculator, I used alpha y equals, and I chose choice 1. And then I typed this expression in. Okay, so for number 5, a standard size golf ball has this diameter. A golf ball is a sphere. The material used to make the golf ball weighs this amount per cubic inch. We want the weight to the ounce. So again, unit analysis, we're going to want the cubic inches gone from the problem. Therefore, we're going to multiply, so we want mass again. So when you're dealing with a sphere, the volume is 4/3 pi r cubed. So I have 4/3 pi, and my radius is going to be half of my diameter. So that's going to be 0.84. And then I want to multiply by this amount. Okay, notice how I changed this to an arrow because it's not equal to. So you just type that into your calculator. As you can see, I left out the cubed, I put it in. You type that in and then round to the nearest hundredth. In question 7, you have a hemispherical water tank. A hemisphere is half of a sphere, so volume would be 1/2 4/3 pi r cubed. Okay, but keep in mind, I can cancel this 1/2 and make this 2/3. The radius for this problem is 5. And then I want, again, cubic feet to cancel out. So I'm going to multiply, and then you just type this into your calculator. Since it's asking me to round to the nearest pound, I look at the tenths place, and the tenths place does not make it round up. Number 9 is a little bit of a different question. So when you're dealing with population density, you're talking about people per square mile. So for each of these, I'm going to type in the population divided by the land area, and then I'm going to look at which one's the largest. Okay, so you can see that that answer was clearly Niagara. So in number 11, they have a similar problem. You have Petri dishes. You have to do a little bit of extra work here. You have to get the area. So you know the area formula is pi r squared. So you have to do the bacteria divided by the area. So on my calculator, what I did is I literally typed in pi, and then I did times parenthesis. I did alpha y equals. I typed in 51/2, got out of the denominator, closed my parentheses squared. And so that gave me this answer of 2042.82. Yada yada. And then I did 40,000 divided by that. I captured the answer off of my calculator. So 40,000 divided by that came out to be 19.58, etc. Then for the other one, I did the same thing. Similarly, I typed in literally pi times parenthesis alpha y equals, chose choice 1, 75/2, went to the right, closed my parentheses squared. That gave me an answer of 4417.86 something or other. And then I did 72,000 divided by, and I captured that answer. And so that came out to be a density of 16.297, etc. So determine in state which Petri dish has the greater population. Okay, so I determined it. Now I have to state it. So I would say Petri dish A has the greater population density after the first hour. At first, when I looked at number 13, I thought, oh, they won't have a problem with that. But then I looked at it again, and I saw that there was this thickness of 1 inch. Lovely. Okay. So first you have to get the volume. So you have the volume equaling length times width times height, but the units have to match. So we have a length of 8, a width of 3, and a thickness of 1/12 of a foot. So again, we want pounds here, so we want cubic feet to dissipate. Therefore, we're going to multiply 43 times this number. So I have 8 times 3 times 1/12 times 43, and you just type that into your calculator. Okay, so I got 86 pounds. Now, taking a look at number 15, why is this worthy of going over? Well, you're given the volume, they're giving you the price per kilogram, and they're giving you the density, and then they're making 500 parts. Woohoo! All right, so we want to know what is the cost of the steel to the nearest dollar. Well, we need to start off by figuring out the grams, then we need to convert that to kilograms, guys, because it's price per kilogram. And then we're going to multiply by the 29 cents per kilogram, and then we have 500 of these, so we need to multiply by 500. All right, so we have this 1015 cubic centimeters times 7.95 grams per cubic centimeter. That's going to give us grams. So this is going to be density. I mean mass. Sorry, my bad. Just kidding, guys. All right, so you type that in. So if you recall down in middle school, King Henry's dead uncle drank chocolate milk. And we have grams, which is just the units. We are going to kilograms, so you need to move the decimal to the left 3 places. So this would be 8.06925 kilograms. And now we have the price, 29 cents per kilograms. So we're going to have 500 times 29 cents per kilogram times the number of kilograms. Type that into your calculator and then round to the nearest dollar. So you get $1,170. Okay, so for number 17, you have new street lights. They're pricing them out. They're talking about the posts for the street lights being 7.5 meters tall and made of aluminum. And then the city can choose to buy the posts shaped like cylinders, or they can be shaped like rectangular prisms. Okay, so I'm going to stop for a moment and draw these pictures. So this problem is heavily calculator involved. So for the cylindrical post, you have to do volume 1 minus volume 2. So it's going to be the entire cylindrical post minus the cord out part. Similarly, for the rectangular prism, it's going to be the entire rectangular prism minus the cord out part. For the cylindrical post, the entire volume would be pi times half of the diameter, which is 26.7 squared times the height. The inner cylinder, since it has a thickness of 2.5, that would be the diameter. We need to divide that by 2, so you get 1.25 squared. So I'm going to type all that in. For the rectangular prism, my outer core is 40 squared times 7.5. That looks a little raised. Let me put that a little bit lower. And then my inner core is 2.5 squared times 7.5. So I'm going to subtract that off. After I get these answers, both of these answers are going to be centimeter cubed. So I'm going to multiply them both by 2.7 to get the density of each. Then after I get the density of each, notice that the cost of aluminum is per kilogram. I'm going to convert my density. So I have to convert after I get my mass. Sorry, I think I said density. So after I get my mass, I'm going to convert that to kilograms. Then I'll multiply by 0.38. So as you can see, I got the densities. And then by multiplying each of those by 2.7, I moved the decimal to the left 3 places. So that's where I have my densities in kilograms. And then after that, I multiplied that by the money rate, 0.38 per kilogram. I got my answers, and so the less expensive design is the rectangular prism. You already knew that that was going to be the less expensive all the way back here when you got the volume, didn't you? Because it was less volume. Because the price for the aluminum didn't change. Okay, however, very smart of them to ask you how much would be saved per streetlight post. So since you want to know how much would be saved, therefore you have to get these answers. So now I'm just going to take my $17,196.03, and I'm just going to subtract my $12,263.91, and therefore the amount saved is $4,932.12. Okay, so you can see that the amount saved would be $4,932.12. So in question number 19, Walter wants to make 100 candles. So instantly that should come out at you in the shape of a cone for his new candle business. The mold shown below will be used to make the candles. Each mold will have a height of 8 inches and a diameter of 3. So that means the radius is 1.5 inches. To the nearest cubic inch, what will be the volume of the 100 candles? Okay, so you're just going to do 100 times pi r squared h. So that's going to be 100. Oh, so each is a cone, sorry. So divided by 3. So pi times 1.5 squared, h is 8, divided by 3. Type that into your calculator. Okay, so you can see I had to get that answer to the nearest cubic inch. So it's 1,885 cubic inches. Then Walter goes to this hobby store to buy wax, and the wax is 10 cents per ounce. If the weight of the wax is 0.52 ounces per cubic inch, how much will it cost Walter to buy the wax for the 100 candles? Okay, so here you have your 1885 cubic inches. You're going to multiply that by 0.52 ounces per cubic inch. That is going to give you the number of ounces. Then you're going to multiply this by 10 cents per ounce. And if you look at unit analysis, the ounces will cancel out, the inches cubed will cancel out, and you'll be left with money. Okay, type that into your calculator. That's going to give you the cost for the 100 candles. So that came out to be $98.02. And then there's an extra component. Walter is spending $37.83, so $37.83 for the molds, and he's charging $1.95 for each candle. What is Walter's profit after selling 100 candles? So since he's pricing it out at $1.95 for each candle times the 100 candles, he's going to get $195 from the sales, but the profit is the sales minus the amount that you laid out. So his profit would be $195 minus $37.83.
What do you want? Huh? Which one? Which drink? Huh? Both. Yes, he wants both.
Oh my God. James, why would you want that much caffeine now at this point? You want that much caffeine at this point? Whatever.
It's not that much caffeine.
Oh, it's not? Okay.
The white tea is very little amount in his drinks.
Oh, okay.
And then the rest of it is just sugar and not caffeination.
All right, whatever. Make sure you do half the sugar for him. Thank you, sweetheart. I appreciate it.
I do 4 pumps usually.
Yeah, he's only beginning to. Ask him.
James, how many pumps do you want? No, the other one.
Just do 3. Thank you, Michael.
No. I'll do 3 and sugar.
All right. Hershey, stop. Okay, so you can see that I put the volume problems here. Okay, a hemisphere is half of a sphere, so I just did half of the sphere. And then I have my cylinder and I have my cone. So before I can get the volume, I have to get the height of the cone. So if I look at the cone, I want this measurement. So I'm going to call this X. But what is this measurement? That is correct, 8.5. Because that is the radius of the cone. And I think that was difficult for kids the year that this was administered, realizing that that 8.5 was also the measure of FD. So we have tan of 47 is opposite over adjacent. And then I'm going to type in tan of 47 into my calculator. I get 1.0724 because you're supposed to round to the 10,000s place. And then I'm going to multiply that by 8.5. So the height is 1.0724 times 8.5. So now I'm going to take these numbers and I'm going to substitute them in. So the hemisphere will be 2/3 pi times 8.5 cubed. The cylinder is going to be pi times 8.5 squared times 25. The cone is going to be 1/3 pi times 8.5 cubed times 1.0724. You see where I got the 8.5 cubed from? Because it was squared, and then I have that extra 8.5. All right, so I'm going to type this entire sum into my calculator. And when I do that, I get the total volume of the water tower. Okay, now we want it to the nearest cubic foot, 7,650 cubic feet. Then they put a restraint on this problem. They say that the water tower was constructed to hold a maximum of 4,000 pounds of water. Water weighs 62.4 pounds per cubic foot, so we're going to get rid of volume, but we're only filling it to 85% of its volume, and we want to know whether or not that exceeds the weight limit. So we need 85% of the volume times 62.4. We need to see whether or not this is less than or equal to 400,000 pounds. So you type this into your calculator and see whether or not it's less than or equal to that. So as you can see, I got 405,756 pounds, which is over the weight limit.